Надаю слово професору Константинові з Донецьку. Вона член Інституту фізико-технологічного інституту Галкіна. Нанокераміка основана на цирконії. Dear participants, I would like to present to you the presentation about the wear-resistant ceramic and composite materials based on zirconia nanopowders for engineering and medicine. Zirconia dioxide is a unique material. It has various properties and is used in construction, parts. It has physical properties, certain properties, and functional, which determine its functional use. And it is the best material as far as biocompatibility is concerned. A number of other properties I will skip just to save some time, but I must say that zirconia dioxide and ceramics based on it, which can be produced by traditional methods from rough dispersed or micron-sized powders, has no properties, has properties that are very important. In particular, hardness, fracture resistance. This ceramics surpasses all other ceramics in fracture resistance due to transformational strength. Besides that, it is resistant against aggressive environment, biocompatibility, and another property very important is wear resistance. And it is the transition to the initial raw material, to nanopowders, as our studies have shown, and other studies, it allows to implement these to apply these unique properties of material. Here you can see the world market of structural ceramics and composites, and it has a very high growth, especially in bioceramics, and of course there is a high potential of growth of investments in this sector of the market. Since we are using nanopowders as raw materials for ceramics, I will show you a short comparative table, comparison table. But at 15 to 2, there will be another presentation which will be solely dedicated to nanopowders and their application. But I would like to note here that the powders and the technology that was developed in Donetsk Technological Institute is unique in its characteristics. And compared to other famous producers, the Nextech, Nano Oxide Corporation, they surpass their ability to obtain It's very important for fundamental research and for application. Besides, you can see here not only the narrow distribution, but technology is also used that it prevents the creation of solid agglomerates. The Nextech technology and powders, you can see additional peak. We don't have solid, hard agglomerates because they're easily destructible. And of course, the price comparison also says in favor of this material as a source for ceramics. These are the data the advantages of zirconium-based ceramics. You see the carbon-based steels, the losses in volume, 100-fold. The zirconium ceramics had 100-fold advantage. And here we calculated the economic advantages. Zirconium-based ceramics, in this case we have 3 years cycle, and since the change occurs once per year, you can see the advantage compared with steel, more than 6-fold. We have conducted analysis of the needs assessment in Ukraine, and we did it because the GIPP program provided to us a grant to have marketing research, to build business plan as a reward for doing one of the partners' projects. You see the demand is rather high and wide in application, but currently there is no production for neither ceramics or powders in Ukraine. The ceramics that could have been used for construction is also absent. The plasma chemical methods, it's hardened and it's not applicable for these use. And now let's talk about the technology of obtaining the ceramics. How so what we need is nanopowder. You see how well dispersed it is, and there's a huge advantage. You see that we produce these particles, these powders, and we can make it with the way we need it for the end product. Besides, as part of this project, we organized a pilot line of producing nanopowders. 10 kilograms per shift. And we have calculated that we can build 1,000 parts for hip joints per month, and it can be even bigger. It is granulated, then pressed, then it is further processed to obtain the shape. And our technology is also allows for green, non-sintered ceramic to make it as close as possible to the end product by using specialized machines. Then the sintering and the final result. Using high pressures, our institute has always led the edge of the science and technology. Besides, we can vary the characteristics of the powder, preliminary treatment, and using CAD/CAM technologies allows for optimized processes. And the low temperatures of sintering allows us to have very good templates. But the most important is that they have excellent properties. Here are some of the examples. Plungers of shaft hydro pumps. They are still made out of alloy steel, and they remain for 2 or 3 months there. Zirconium plungers. We have some examples on the Sachko mine shaft. They stayed there for more than 100 months. We guarantee 9 years of life cycle. So these are unique materials priceless for those of you who understand what we're talking about. And another example is the jettisons, the jets for cleaning the alkali residue. They're in a huge demand abroad. We have tested it in Mariupol factory, and Mariupol factory shown at these examples, but they still buy abroad somewhat. Another thing, these are the nozzles for sandblasters. And another thing that I wanted to tell you is composite building. We suggested this new methodology of making the composite. It is unique in the way that the future properties are formed on the molecular level. We introduced a third component, non-stabilizing, during the precipitation phase. Plus, we have an opportunity to manage to adjust this additive. As it is on the borders of grains, and as we vary the amount of additive, we can adjust the borders of the particles, different concentrations. No less interesting are heat-resistant properties of the ceramics. We have been addressed by the company Puyang Pyramid to produce dosage vessels for iron casting. It should be a porous material, but still we managed to produce much cheaper products. And then you can see on this slide some of our first ceramic crucibles, especially valuable for those who melt metals and work with the molds. They're highly heat resistant, highly resistant to thermal shocks, and there's no interaction of the melt with the walls. Next thing I want to say is the medical applications. We have worked here together with the Institute of Super Hard Materials, and they have tested our ceramics, and they show that our samples had withstood 1 million cycles, and friction coefficient at from the initial 0.04 was even better by the end of the cycle, 0.08. And just recently we have submitted all the promo materials to speed up the production of such prostheses, because we also have titanium nanostructured production, and it's worth discussing. Another example, no less important for us, is production of the blocks for prostheses, for dental implants. We have selected specific designs, and CAD/CAM technology allows us to successfully market this technology. The nanopowder ceramics can be completely non-degradable, and we seriously claim that. What we can do now, we can produce small batches. We can do customized batches. We can even look at using new compositor. Besides that, we're ready to sell our ceramics in small batches, but we think that we can organize industrial large-scale production or through a startup. This is a short description of results and the business plan that we had compiled. The cost of this, it's not on the slide, but it's 37 million hryvnias. And we're quite open for discussion for those interested parties. Thank you. Now, this is an example of beautifully done presentation. Quite optimistic, clear, concise. Another company that had expressed an interest in the things that we produce. They are ready to buy, but they cannot invest in the development. So the problem was to organize the development, to somehow facilitate it. Another problem is to organize the raw materials for nanopowders. We have huge deposits necessary for zirconia dioxide. The two factories are still suspended. And Dnipropetrovsk promises to resume their production, but we can work on the Chinese raw materials. Thank you. But it's much worse than our raw materials. Yeah, are there any questions? Please. These joint parts.
Мікрофон задавайте, будь ласка, запитання.
Based on sapphire-based powders. So, if you know your powders, you know that sapphire powders has anisotropy, and the head of the joint does not withstand the necessary type of cycle. Although otherwise the material is very good, but anisotropy is a very important negative property, unfortunately. And as far as I understand, in Ukraine, the producers of ceramic implants, there are no such producers that would already market their products. There are some experiments, though. There are huge potential for application in the medicine. Hip joints, and as I know, our colleagues went to Germany. Have you tried to contact them? Especially as pertains dental implants. It's a huge market in Ukraine, as we think the medical science on a very high level. Have you contacted them directly? Yeah, we did, long time ago. Just recently, the Cabinet of Ministers and the presiding board, they mentioned this thing. Okay, in our country, we have a production structure non-degradable. That's the problem. I don't have a question, just a remark of those people who have attended our meeting. We have NPC Science, we have the company Labs, we have the company Noplex, we have Bioautomotive, we have two representatives of the US Embassy, we have the company Bishma, we have the company Mergy Group, and the company Tigra. So we have some companies present here. Then there's a fund of support of entrepreneurship, Madam Chernina. Maybe some of the non-scientific organization will speak out during the discussion. Thank you.